Welcome to Unit 4, which is the final unit in this first module on the nature of science, where we're going to sum up all of the ideas and look at some contemporary views of the nature of science. And by that I mean ones that we'd like to convey to our students in the classroom. So contemporary views of the nature of science. So we've probably all heard of this term scientific literacy, and current reforms in science education really emphasise that we need to teach science for all, with the ultimate goal of developing scientific literacy. And so the idea with this is that sort of 40 or 50 years ago, Year 11 and 12 was primarily designed for educating the elite, or educating those students that were going to go on, the very small minority that were going to go on to tertiary education. And as we know, the large majority of students now complete Year 12, and almost at least half of those are entering into first year university courses. So really our goals for science have changed a lot, and we revisit these quite a lot in our last lecture, or our last module, where we look at some of these reforms. So what we want to do is we want to go beyond simply teaching science as a body of knowledge. Okay, so that's no longer our primary goal. Now, even though that is an important component, and the development of knowledge in the sciences is very important, but it's not the only focus. So today's teachers are challenged to engage students in a broader view of science, one that addresses the development of scientific knowledge and the very nature of the knowledge itself. And that's what we're really doing in this course. This is our focus. It's not just learning the laws of science. It's not simply just learning processes of science. It's the why. Why do we learn science? What impact does that have on society and on our learners? So that's an important component of it. So in other words, science teachers are increasingly being encouraged, and according to our new Australian curriculum, they're required to teach about the nature of science. And the nature of science falls under the science as a human endeavour broad categorisation. So we have our science understanding strand, we have our science inquiry skills strand, and we have our science as a human endeavour strand. So all are really important components of student science education. So here's some of the ideas that we want you to promote to students, and we've touched on these all throughout the units. But the number one thing, science is tentative. It's really important that our students understand that what they read in textbooks and the way it's presented does not imply that science doesn't change. So we know that all scientific knowledge is subject to change in light of new evidence and new ways of thinking. Even scientific laws can change. So new ideas in science are often received with a degree of skepticism, especially if they're contrary to well-established scientific concepts. And we've got a really great example of how new ideas have to sort of fight their way into existence when we look at the second module, which looks at history of science. And we're going to examine some ideas in astronomy, which you may find quite surprising. On the other hand, scientific knowledge, once generally accepted, can be robust and durable. So what that means is that scientific knowledge, even though it can change, most of the time the large majority of concepts don't change. So many ideas in science have survived repeated challenges and have remained largely unchanged for hundreds of years. So you can have confidence in science. This is another important point, is that we don't want our students to go from what we call absolutists, where they think nothing changes, to relativists, where they think everything can change, so why would we bother? We want them to sort of have a nice middle ground where they know, okay, well, we can be skeptical, but if evidence is there, then perhaps we can have confidence. Science is empirical. Now, this term is one you've probably heard, but you may not understand. So we say scientific knowledge relies heavily on empirical evidence. And by empirical, we mean the data that we collect to support our assertions. So it can be quantitative, so it can be data that's expressed in numbers, or it can be qualitative. It can be observational data, which is different in its nature, but still very valuable. So while some scientific concepts are highly theoretical, in that they're derived primarily from logic and reasoning, ultimately all scientific ideas must conform to observational or experimental data to be considered valid. So this is one of the hallmarks of science, is that science relies on evidence. And evidence is really important. We can't just speculate something or put an idea forward without having evidence to support it. The third one, science is inferential. So an inference is an explanation for an observation. So yes, we collect observations as scientists, but we need to go beyond that. We need to gather our information, but then we need to say, well, so what? We need to use our previous knowledge, add that to our observation, and start forming some explanations and inferences. So science involves more than just the accumulation of countless observations. Rather, it's derived from a combination of observation and inference. And particularly with the inference is where a lot of that creativity comes in. So observation refers to using the 5 senses to gather information, often augmented with technology. Inference involves developing explanations from observations and often involves entities that are not directly observable. Okay, so inference, when we're looking at those models of the atom, is particularly important in that we have some indirect evidence and then scientists have to put those ideas together with what they already know to try and develop their explanations. Scientific laws and theories. So in science, a law is a succinct description of the relationship or patterns in nature, which is consistently observed. Laws are often expressed in mathematical terms, whereas a scientific theory is a well-supported explanation of natural phenomena. So it's not talking so much, it's not focusing on just the relationship between different components. It's then going beyond that and saying, okay, so we have this law, what does this mean? What does it help explain? So they're different types of knowledge. One can't change into the other. It's like apples and oranges. They're just different types of knowledge. But on the other hand, they're similar in that they both have substantial supporting evidence and they're widely accepted by scientists. But importantly, either can change in light of new evidence. It's not to say that that change is common, but it's possible. Scientific methods. It's important for our students to know there's no single universal scientific method. There's not one way to do science. Even though we do lots of experiments, particularly in junior secondary, that's only one way for us to generate scientific knowledge. We can use observation, inference, discovery, experimentation. There's a range of methods. Creativity is really important. So creativity is a source of innovation and inspiration in science. But beyond that, scientists use creativity and imagination throughout their investigations. It doesn't just come at the end. They're always being creative. It doesn't mean they're not rigorous. The two are not mutually exclusive. Objectivity and subjectivity. Scientists tend to be skeptical and apply self-checking mechanisms such as peer review in order to improve objectivity. What that means is when scientists portray their findings to others, such as through journal articles, those journal articles are critically evaluated by their peers. By peers, I mean people that are in the same field and have expertise in that area. So, scientific knowledge, and we're going to look at this in a later module, goes through a process of self-checking mechanisms. Sometimes that process itself can be flawed, which we'll see, but they do tend to be skeptical. They're not just these sterile, objective, lab coat type personas that we often portray. On the other hand, intuition, personal beliefs, societal values all play significant roles in the development of scientific knowledge. Thus, subjectivity can never be, nor should it be, completely eliminated from the scientific enterprise because science is done by humans. So that's a nice little summary. I'd like you now to reflect back on your questionnaire that you completed at the beginning of Module 1, so in Unit 1. Have a look back now at your responses and see if you change any of them now or see if they've developed from what you had originally put down. It'd be really nice to know how your understandings might have changed or modified. So if you could share some of those ideas on the discussion board, that'd be fantastic. When you're happy with doing all of that and reviewed all 4 units, you can go in and complete your first quiz, which is Quiz 1, Nature of Science, which is now available. So you can go in and complete that when you feel confident that you've got your head around these concepts. Remember, you can have your notes with you when you complete that quiz. And finally, we're going to have a look at Portfolio Item 1, which corresponds to this first module on Nature of Science. So if you cast your mind back to Unit 3, just 1 unit ago, we looked at some criteria for characterising science. What I want you to do is I want you to take those 6 criteria And I want you to investigate the field of creation science or creationism. You can Google those terms. You can bring up a bunch of articles about it. Try and determine for me whether you would call it a science, an emerging science, a non-science, or a false science. So I want you to make a recommendation to me based on your evidence. So to do that, you are going to need to go online and have a look at some websites about creation science, and be mindful, some of them are developed by particular groups that have their own agendas. So have a look at who's authoring the information that you're accessing. So look at this criteria. So to qualify as science, all 6 criteria must be satisfied. So you have to decide whether all 6 are satisfied, and you need to tell me how. So if we're going to call it an emerging science, 4 to 5 criteria, and a non-science or a false science would have 3 or less. So you're going to do some investigating and give me an overall recommendation. I'm going to show you 2 examples of students' work for this particular item that you can have a brief look at to guide you. So we talked about creationism a little bit in the slides, but you will need to go and do that little bit of investigating. Round about 1.5 to 2 pages A4 in length for this item. And we're going to have a look at some sample items now. So here is a student's sample of work. I'm very familiar with this sample, as I am for the next sample, so please don't, plagiarize this, because I will recognize it when I mark it. So this is someone's response. What they've done well is that they've taken each of the 6 characteristics and outlined how the particular creation theory they've looked at addresses it or doesn't, which is good, because I like to see how it aligns to each of the 6. So don't just give me a paragraph saying, well, I don't think creation science is science because it doesn't satisfy them. I need to know how. So that part they did well. They gave me an overall recommendation, which was quite good. They didn't give me any links to websites they used. Now, when I show you on the portfolio item criteria sheet why that's important, you'll understand why I'm asking for that. So this one was okay. Okay, here's a second example. You can see probably straight up that it's well presented, probably a little better than the other. One good thing to think about is presentation. These are items that you might want to use again, so having it well presented is nice. This one gave me a little bit about what creationism actually is, and when you do some investigating, you realise there are different types of creationism. So there's old Earth, there's young Earth, there's different types. So let me know which one you're talking about. That would be a really helpful hint. This one actually bunched some of the criteria, which is okay, as long as I can clearly see each criteria is addressed. This is nice. Primaries are so good at making it really like a story. But the important part is these useful websites. They provided the URL, the title, and even a brief description of the website. This is a great thing to do, and I'll show you why when we look at the criteria sheet. So here's the criteria sheet for the portfolio. And if we go to item 1, which is exactly what's on that slide, you'll see here it has 5 marks and it addresses criteria 1 and 3. So when you go down to the criteria sheet, here's criteria 1, here's portfolio item 1. So to get up here in outstanding, you need to give me a highly accurate and detailed understanding of all criteria for classifying science in your written part. And then if we look at criterion 3, so it doesn't address this second one, this particular item, but it does address this third one, critical analysis of reading and online materials and accurate interpretations of the evidence presented in an innovative, reflective manner. You can see what I want. So if you want to do well for portfolio item 1, you need to critically analyse the material from 5 or more reputable websites. Okay, and as you can see, go down the list here. It's less and less websites, it's less and less referencing of which sites they were. Interpretations presented in an innovative manner, explicit referencing. In other words, you don't need to reference in text, but you need to provide that nice list at the end, which gives me the URLs, the titles, and a little summary of the website. All right, so always refer back to these criteria sheets because this is what you need to do. If you do that, you get that mark. So it's that simple. Okay, so I'm going to stop and we are going to move on to our second module, which is History of Science. Please let me know if you have any questions or concerns with this one, and I look forward to presenting the second module.